Hello everybody and welcome to my discrete random variable video. So without further ado, shall we go ahead and let's go ahead and begin. So let's just consider the following experiment that we are going to roll two fair six-sided die, and what we'd like to do is to consider the outcome of summing these two six-sided die. So these are all 36 outcomes right here. And I think if we were to take a look at what can the sum of two six-sided die be, I think it's easy to see from this picture or using your intuition that we can easily see that the outcomes are the integer values 2 through 12. All right, because these are integer values or discrete, going back to this discrete versus continuous that we learned about a few chapters back. All right, these are discrete 2 through 12 integer values. So let's just note that a discrete probability distribution for a random variable then is a listing, usually in a table, of all the possible values of the random variable along with their corresponding probabilities. So once we have the values that the random variable can take on, along with their associated probability, we know everything we need to know and can answer all questions about that particular probability distribution. The requirements for the distribution are, these should be familiar, is that the sum of the probabilities must be 1 and that the probabilities also have to live between 0 and 1. Can't have anything bigger than 1, and we cannot have any negative numbers. If you happen to end up with a number bigger than 1 or a negative number, that should send a red flag. So let's just come back over here and let's take a look to see if we can't figure out the value probabilities. So here earlier we stated that the values of the sums can be integer values 2 through 12. So here's that listing. And now we have to compute the probabilities. So again, we have all 36 outcomes. So the sum is 2. Well, notice that that only corresponds to a value of 1, 1. So let's just note that that occurs one time. So the probability is 1 over 36. The probability that the sum is 3 is this one and this one. So 2, 1 and 1, 2. So there are two ways that that could happen. So we have a probability of 2 over 36. The probability that the sum is 4, 3, 1, 2, 2, 1, 3. There's only 3 outcomes out of the 36. So the probability that the sum is 4 is 3 over 36. And I'm thinking that maybe you're starting to see a pattern here. The probability that the sum is 5 is 4, 1, 3, 2, 2, 3, and 1, 4. So the probability, those 4 out of the 36. And if you want, you can pause the video and just double check these probabilities for yourself, and then go ahead and restart the video. All right, so this forms our discrete probability. So let's just note that each one of these individual probabilities are all between 0 and 1. And let's just observe that 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 5 is 26, plus 4 is 30, 33, 35, and here we get 36 over 36. This is one of the reasons why I did not reduce these fractions, because I knew I had to do that, and plus that was a good exercise on seeing if I can add up a bunch of numbers here. All right, so the next thing that we would like to do is to take a look at interpreting from English to what we call random variable notation. So I have these 5 statements here. I'd like to go through maybe the top 3 and then pause the video and have you go ahead and do the last 2. So the sum is 10. So let's focus on the sum is 10. So to write this using random variable notation, let's just note that this says that the probability that x is equal to 10. So this is how we write this: the sum is 10, or actually more, to be more accurate, would be the probability that the sum is 10. So writing this probability statement here. And then all I have to do is come over here and read this right off the table. And notice that it's 3 over 36. And when you go to enter your final answers, be sure that you reduce your fractions. I did post an announcement on a Desmos calculator. You can either download the app to your mobile device or your laptop or whatever, and feel free to use it on your cell phone. But I'm not interested in having you manually do these, so please feel free to have technology reduce the fractions for you if you don't know how to do it in your calculator. So coming back, the next one is the sum is 13. So focusing on the sum is 13, let's just note in random variable, this is the probability that x equals 13. And notice that this has to be 0 because this event cannot happen. Our next one is the sum is less than 6. So focusing on the sum is less than 6, in random variable notation, we would write it this way. And let's just note that there's a difference between the sum is less than 6 and that the sum is no more than 6. The no more than 6 would mean that you would include the 6. So let's just note, to compute this, the sum is less than 6 means that the probability it could equal 2 or 3 or 4 or 5. All right, so notice that the sum is less than 6 can only take on these values 2 through 5. And notice that if I add these up, I get this row here should come out to 10 over 36, which then reduces to 5 over 18. All right, so I've taken care of the parts A through C on an individual basis. If you'd like, please feel free to pause the video and then go ahead and write out in random variable notation the sum is more than 10 and 5 and 9 inclusive, and then go ahead and compute their probabilities, and don't forget to reduce your fractions. Okay, so the probability that the sum is more than 10 is the probability that x is greater than 10, which, coming over here, greater than 10 just means it can be 11 or 12. So 11 or 12, 3 over 36. Hopefully you came up with 112. That the sum is between 5 and 9. And this is a key word, inclusive. If that inclusive word was not there, then we wouldn't know whether to include the 5, the 9, or both 5 and 9. But because the word inclusive is there, notice that when we write the probability statement, we do include the 5 and the 9. So notice that the probability of 5 is 4 over 36, probability of 6 is 5 over 36, probability of 7 is 6 over 36, and the probability of 8 is 5 over 36, and the probability of 9 is 4 over 36. These should add up to 24 over 36, which I got 2/3 when we go to reduce. Let's see. 4, 9, 15, 24. So 24 over 36. So hopefully that's what you got. All right, let's move on to our last topic, and that would be the mean and the standard deviation of a discrete random variable. And I would like to throw out that in this video, I will show you how to do this manually with a very small table, but I do have another video that is posted as to how to use StatCrunch, and I will probably go back and show you how to compute the mean and the standard deviation with StatCrunch using regarding our dice rolling example. So let's just note that for the mean, it's denoted by the Greek letter mu. This should look familiar to us from back in chapter 3 on our parameters of a probability of, the parameters when we have numerical summaries of a population data set. But in this case, notice it says to take the random variable x, multiply it by its associated probability, and we're going to add those up. So let's see this in action. So here I just have this small table where I have the x takes on the values 2, 3, and 4, along with their associated probabilities. So let's just note that to compute the mean, mu, we take the value 2 and multiply it by 20.26, so I get that. We take the value of 3 times its associated probability, and then we take the value of 4 times its associated probability. And notice that when I perform this computation, I get a mean of 3.12. So what does this mean? All right, so the idea is that if you were to perform this experiment, say, 10 times, now because 4 is the highest, 3 is the next highest probability, I would expect to see 4 the most and 3 the next. So I probably would perform this and I would get something like 4, 4, 3, 4, 2, 3, 3, 4, 4, and then maybe a 2. So that would be 10 times. So again, adding up and dividing by 10, that would give me a value. But the idea here is, what if I increase from 10 to 50? And again, I'm going to have a bunch of 2, 3s, and 4s, probably a lot of 4s, a lot of 3s, and some 2s. And again, if I add those up and then divide by 50. And if I repeat again, say 100 times, well, then the question is what if I just let this thing go? And so the idea is, if I compute each one of those x bars for 10, for 50, for 100, then for each time, as the sample size gets bigger, that these x bars all will converge to the true mean. And this is the mean of the random variable at 3.12. And again, hopefully it kind of makes sense, because this 4 has got a probability of 0.38, and this 3 has a probability of 0.26. So probably right in here is kind of the weighted right here would be the center of the distribution of these random variables, again, based on these weights. All right, the next thing we'd like to compute is the variance and the standard deviation. So let's just note that the variance is x squared, so we take the value of the random variable and we square it, multiply it by its associated probability, and then add them up. And after doing that, don't forget to subtract off the mean squared. And we denote the variance again here as sigma squared. Once we have this computed, we take the square root of both sides, and this gives us the standard deviation. So let's see this in action. All right, so again, the formula says take 2 and square it, multiply it by its probability. Take 3 and square it, multiply it by its probability. Take 4 and square it, multiply it by its probability. Add all of those up and then subtract by its mean squared. So notice that this is exactly what I did. And if you'd like, please feel free to pause the video and double check the computation. And this will be your doing it by hand. Again, I will show you how to use StatCrunch for a larger data set, but this one is kind of manageable. So notice I get 0.6256. And then to get the standard deviation, to linearize the units here, I take the square root of 0.6256, which gives me 0.7909, and this is the standard deviation. So again, this is probably everything about a discrete distribution that you wanted to know about, and everything you need to know about. So it's pretty simple on a discrete distribution. I have another video coming up regarding the binomial distribution and what it is and how to compute those probabilities, and you will probably want to use some form of technology to do that. So this brings us to the end of our video, and I hope that regarding a discrete distribution, this helps to clear out some of the things. All right, thanks a lot.